Alright, so we're going to do an example with Mohr circle. In Mohr circles problems are just, when you're given a state of stress, like the one here, with normal stresses and shear stresses shown, often you're asked to find the state of stress at a new angle of orientation, or the principal stresses and the maximum in-plane shear stresses are common questions, and drawing that representative volume element afterwards. Uh, for the principal stress state and maximum in-plane shear stress state, Mohr circle is really well suited for that. I think that might be the fastest way to get there, um, as compared to like using the stress transformation equations. One of the first things you want to do is is draw that coordinate system. So one is coordinate systems, okay? Coordinate system for the representative volume, or it's the stress state that's given to you. And here you just define a your positive x direction. So here I'm going to say just standard positive x to the right, positive y upwards. So wherever I draw x, y tags along according to the right hand rule. Okay, I could have drawn x going upwards and y going to the left, x going to the left and y going down, whatever. Okay, I could have done anything, but these coordinates are important in establishing the directions, and then that way you can get the proper sign convention for the stress, when you label the stresses. So here, the second thing to do is really label stresses, or define stresses. Define stresses here. And these stresses here, so in this case here, sigma x is equal to a positive 1 ksi because it's causing tension, or it's in the positive x direction. So 1 ksi. Sigma y here, over here, it's 2 ksi causing compression on that face, so minus 2 ksi here. And then the shear stress, tau xy, here, I am on the x face. Here's my x face in the negative y direction. So a positive times a negative gives me a negative, and therefore this would be minus 3 ksi. And this even works over here on this face. I am on the positive y face in the negative x direction, so positive times negative. Or over here, I'm on the negative y face in the plus x direction, which also leads me to negative 3 ksi. Okay, and so once I have my stress state set up, it's up to you to choose stress transformation equations or Mohr circle or whatever you want to do to determine whatever the question's asking. All right, so in this case, we're going to use Mohr circle because, hey, this is an example of Mohr circle. All right, and the first thing you want to do for Mohr circle to come up with that is the center of the circle. And the center of Mohr circle is the center, I'll use note C, is sigma average comma 0. And that sigma average is the average of the normal stresses. So sigma average is equal to 1 plus negative 2 divided by 2. And this is the average of the normal stresses, sigma x plus sigma y divided by 2. And so here, this is minus 1/2 ksi. Okay? So there's the center of Mohr circle. The next thing you need is like a point on the outer radius, okay? That point on the outer radius represents this face right here. It represents that face right there, okay? The x face, the plus x face, or theta equals 0 degrees, okay? So this point on the outer radius we'll call point A right here, and A is just sigma x tau xy. So point A is 1 comma minus 3. And now we're ready to draw those points on a coordinate system. Okay, so here, 5, draw. Mohr circle, or the circle of stress, whatever. Okay, now here, let's see here. So I have, I find it's easier to draw the circle first. And if you have like a nice little coffee cup cap or something, it's kind of a useful, handy tool to have to draw a nice, clean circle. So here I'm going to draw more circle first. Then I'm going to draw a circle first. Okay? Sometimes you don't even need to draw the circle, but here in this case, I'll draw the circle first, right here, so that I have a nice-looking circle that looks relatively nice. And let's see, here is about the center of the circle is right about here, so I'll draw my horizontal axis. And then I know that the center of the circle right here is about minus 0.5 comma 0. Okay, so that's minus 0.5 comma 0. That's the center of the circle. So I have to figure out, like, okay, so maybe right about here, and So here, this would be about the 0. So here's my vertical axis right about here. I'll call that my vertical axis. Then, so here's plus sigma plus tau. Here's that direction. You know, if you have nice graph paper, you draw the axes first. You'll dot the center, and then you'll do you'll draw out point A. Point A would be, let's see, boom, 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 right about here. This would be point A, and this would represent 1 minus 3. 1 minus 3 right there. Okay, 1 minus 3. All these in units of KSI. Okay, so there's no issues about units. And you draw a Mohr circle. So in what you might normally do if you have nice graph paper, you have engineering paper with all the grid lines and things, you'll draw this point first, you'll draw this point next, and then you'll draw a line if you got a nice compass or something, and you'll make it, right? But whenever I do that, I end up with sloppy circles, okay? And they just, it's just ghetto. All right, so check this out. The rest of this, right, now, one of the most important things you need is the radius of the circle. So, calculate the radius. So the radius of the circle is this line right here. Whoa, okay, right here. Here's this radius right here, okay? And here we know that this point right here is 1, okay? And this total distance going from here to here, this distance right here, what is that? That's 1.5 right there. Okay, if this is the 1 marker, right, this total distance is 1.5, and this distance right here is 3. That's 3. So the radius of my circle here, the radius is the square root of 1.5 squared plus 3 squared. Okay, and I've neglected the negative sign or anything like that because it's going to be squared. And so here, if I do my calculator, this is going to be 3.35 KSI. And this is the radius of my circle. Okay. And so now the question is, what is my principal stress state? So the principal stresses here, so I have this right here. So the thing to note, okay, the principal stresses are essentially the states where the shear stresses are 0. And in Mohr circle, the shear stresses are 0 on this line right here. On this line right here. So this point right here, this first point represents the major principal stress, sigma 1. The major principal stress being the most positive principal stress in this here, okay, right here, and this is the least positive principal stress, sigma 2, the minor, right here. Okay, so if I look at this right here, I know that this distance right here is r. And I know that this distance is also r right here. So the coordinate of sigma 1 is r minus, the distance to the center of the circle. R minus, let's use purple. R minus this distance right here. The coordinate sigma 1. So sigma 1 right here, just based on geometry, my principal stresses. So let me do the principal stresses over here. Let's call these principal stresses. You can read that. Principal stresses right here. And here, sigma 1 is just R, which is 3.35 KSI, minus, is this distance right here is sigma 1 right there. That's sigma 1. It's 3.35 KSI minus 0.5 KSI, which is 2.85 KSI. Yes, I think that's right. 2.85 KSI right there. Bam. Okay. And then sigma 2 is the coordinate over here at sigma 2, which is this distance right here. That red line to the left is sigma 2. And sigma 2 is 3.35 KSI, and it's negative because it's over here to the left of 0, if you will, and it's negative plus negative 0.5, minus 0.5 KSI, and this is minus 3.85 KSI. Yes. Okay. Minus 3.85 KSI. That looks good. So my two principal, my major and my minor principal stresses are 3.35 and minus 3.85 KSI. Now, now what I need to do, okay, if I have enough space over here, is draw the representative volume element. Now I want to draw the RVE for principal stresses. Okay, and this in the principal in drawing the RVE is nice because it's like being able to look at the whole answer in just one drawing.